The oil palm is a plant typical of hot tropical regions and is found in Colombia, its first producer in Latin America and the fourth worldwide. The Oleoflores guineensis, as it is scientifically known, is a perennial crop, which means that it can bear fruit for more than 25 years, reaching heights of approximately 13 to 15 meters. It is considered the most efficient crop in oil production per hectare per year, giving up to 6 times more yield than soybeans. Its production and cultivation process requires a correct selection of seeds, careful planting procedures between nurseries, and in the field, optimal soils and constant irrigation that allow the palm to grow healthy clusters with fruits that will later be transformed into finished products such as cooking oils, margarines, soaps, makeup and fuel such as biodiesel, which makes it present in almost all the products we use daily. To better understand this process, we traveled to the extraction and transformation plant of the Oleoflores Business Group located in the municipality of Agustin Codazzi in the department of Cesar in Colombia. The bunches are taken to this place, which has a capacity of 45 tons of palm fruit processing per hour, once harvested in a state of maturity suitable for the extraction of the oil. The fruit arrives at the extraction plant in different types of vehicles. It can arrive in trucks, it can arrive in dump trucks, it can arrive in trucks, or it can arrive in foxes. That vehicle arrives here at the company, it is weighed on the truck scale and goes to the fruit reception area. In the fruit reception area these vehicles are unloaded into a hopper. The fruit is stored in the hopper and then unloaded into wagons. The wagons are like train trolleys. We store and fill the wagons and proceed to sterilization. In sterilization we take the fruit that is raw, that comes from the crop, and we cook it using saturated steam. The main objective of sterilizing the fruit is to soften the pulp to remove the oil that is inside the pulp. Once we have cooked the fruit, we proceed to vacate the wagons that we had previously filled. This is done in a piece of equipment that is called a tumbling drum. Once we have vacated the cooked fruit, we proceed to go to the enjoyment plant. The function of the enjoyment plant is very simple. We want to separate the seeds of the bunch from the bunch. Then in this part of the process we are divided into 2 streams. One is the fruit brought by the raceme and the other is the bunch without seeds, which we know as rachis. That rachis here at Oleoflores is taken to a rachis plant, where we press it to remove the liquid part and obtain a pressed rachis with a lower humidity. That pressed rachis is taken to our composting plant, where we integrate it with the effluents of the complex to make an organic fertilizer or compost. We are currently in the composting plant and the oxidation ponds of the company Oleoflores SAS. This area is where all the solid and liquid waste from the palm oil extraction process arrives. among which we mainly have the effluents, the liquid waste that you see here. We can see that these are waters that are highly polluting, and if they do not receive a previous treatment, it generates a negative impact on the ecosystems. We have different stages of the process. After passing through the oxidation ponds area, we carry out an anaerobic treatment, in which we use a lagoon area made up of 8 lagoons, in which different stages are carried out until we obtain a reduction of the organic load of this fluid and a stabilization where the water can be reused either for cultivation or for irrigation of our compost. As I said at the beginning, initially here we also receive all the solid waste from the extraction plant. Mainly and in greater volume what is generated is the rachis. The rachis is the fiber that normally supports the fruit. After we arrive at the shelling process in the extraction plant, we extract the fruit and we are left with this amount of fiber that is mainly composed of hemicellulose, lignin and cellulose. Also in the part of the fruit that is composed, that which contains the oil in the fruit is composed of a fiber, mesocarp fiber, which is what we have here and are the main raw materials that we use for the preparation of our compost. We also have the filter soils that are obtained after the process of bleaching the oil in the refinery part. We in the composting process. What does it consist of? We make these piles that you can see in the background, in which we make a proportionate mixture of all these wastes that will depend strictly on how they are generated in the industrial process. These materials are arranged as you can see, and they are provided in piles. In piles that are like a row, yes. Initially we receive the rachis. As you can see at the bottom, the rachis arrives with the loader. With the help of the loader we begin to form the row, which has a capacity of approximately 100 tons, each row can hold up to 100 tons of material, of rachis. To these 100 tons of material we add 25% or 20% depending on how it is generated in the plant. In the fiber and exhausted soil extraction plant we are adding approximately 5 or 3% also depending on how it is generated in the extraction plant. After we have that, we have the pile already formed with all the ingredients. It has an approximate weight of 130 tons of compost, of material to compost. Pre-composted, this process, we begin the hydration of the piles. How do we hydrate it? In the first stages we use the raw effluent. When the pile is in its intermediate stages, we use the logos from the bottoms that we extract from the bottoms of the lagoons, and with this what we do is to take advantage of everything that is generated there to enrich this material and take it until we have a finished product that is a totally fine, totally stable compost with high agronomic value that can be and that is normally used in our plantations. This is an aerobic process, which is carried out through microorganisms that work on the basis of oxygen, and we need to put air into the pile. We do this with an aeration machine that allows us to turn the pile frequently. What is the purpose of this turning? First we have to improve the granulometry. To go from this expected fiber that we have to have a product of a finer granulometry, more stable. We also incorporate oxygen, and we help that the humidity does not turn the pile into an anaerobic material and rotting is generated. At the end of the 90-day process, approximately, we obtain a compost product, which we submit. We take it to some stockpiles and we keep it, we store it. We dry it, and that allows us to take it to use it in our own farms. Normally we are producing around 1,500 to 1,800 tons per month. Everything will obviously depend on the process flow generated by the extraction plant. We go back to the disfrutador. In the disfrutador on the other side we already have the fruit. We take this fruit to the next stage of the process, which is the digestion and pressing. In the digestion, as its name indicates, what we want is to digest the fruit. Imagine that this is like when you make a juice at home and you put it in to the blender. It is the same process but in an industrial equipment called digester. Once the fruit is digested we put it to the pressing. The pressing here is done in a double screw press, where the press takes the pulp, presses it and removes the liquid part. Then here the process returns and is divided into two streams. One the liquid part and the other the solid part. The solid part is composed of the fiber and the nut. The nut is the seed of the fruit. This stream is separated through a pneumatic separation column, which is a column through which an air stream passes. From this air stream from the top is taken to the lighter phase, which in this case is the fiber, which ends up reaching the boilers, and from the bottom we have the nut. The kernel goes to the palm kernel process, where we try to recover the kernel that is inside the kernel. Then we take the kernel to a sorting drum and then we pass it to a 1000 rifle type breakers. The breakers break the kernel. By breaking the kernel we can release the kernel and separate it from the shell. Again we make a pneumatic separation. We remove the shell from the mixture and we take it to the boilers. Our boilers are fed with both fiber and shell and we store the kernel, dry it and process it in our speller plant. In the speller plant what we are looking for is to remove the oil from the kernel as crude palm kernel oil. So here we obtain two processes. Two products, one is the crude palm kernel oil contained in a kernel and the other is what is left of the kernel when we remove the oil, which is the palm kernel cake or flour. We go back to the presses. We are already one for the solid part which is the fiber and the nut. And we are left with the liquid part which is the liquid part that comes out of the presses. It is a mixture composed of crude palm oil, water and sludge. We have to separate the sludge and the water from the oil. How do we do it? We take it to a process stage called clarification. The clarification of the oil begins with a static separation in tanks where we let the mixture rest. We subject it to a temperature of approximately 80 to 95 degrees and as oil and water are immiscible substances they will separate. Then here we form three layers: the oil, the sludge and the water. Then when we let it rest, we can take out the oil from the top, the sludge and the water. As these sludges still have an important oil content, we take them to a dynamic separation because the static separation is not enough to remove all the oil from the sludge. This dynamic separation is carried out in equipment called sliding centrifuges, which as its name indicates, use centrifugal force to separate the oil from the sludge. Once we are sure that the oil is oil-free, it leaves the process as the final effluent of the process and goes to the composting plant. The oil still needs one more process to finish cleaning it, which is a drying process to reduce moisture and a sedimentation process to remove any impurities it may have, and with that we deliver a crude palm oil, dry and without impurities for further processing, which are the transformation processes. Once the crude oil is extracted at the extraction plant, tanks are stored and the transformation process begins. At this moment the flour plant has 4 important transformation processes: physical refining, biodiesel fractionation and margarines. In the refining process, what we try to do is to eliminate the compounds that are seen and not seen in the crude palm oil. Among the compounds that are seen are what are called impurities, and those that are not seen we have the gums, mucilages, metals, and other elements, and under a process of steam dragging and high temperature all the beta-carotenes are removed. All the impurities, all the acidity and the oil passes. The crude palm oil goes from a red color to a greenish-yellow color, and that is the final oil that we have as RBD oil. It is the refined, bleached and deauthorized oil, that is the raw material for the production of biodiesel, the raw material for fractionation and raw material for margarines. The process subsequent to refining is called fractionation. Palm oil has the particularity of having 2 phases, one solid and one liquid. The liquid phase is called olein and the solid phase is called esterin. Then we take the RBD oil and we take it to controlled temperatures from 65 to 70 degrees to 18 to 17 degrees centigrade, forming crystals. These crystals then pass, or this oil passes through a filter, that is, the liquid mass becomes a little pasty, and under pressure, the oil is pressed and the crystals are broken, and we obtain the liquid phase and the solid phase of the RBD oil. The olein is the one normally used for packaging, and the esterin can be used in packaging processes, margarines and biodiesel, among others. The liquid phase, as I mentioned a moment ago, is the olein, which is the common vegetable oil that we see in any kitchen in Colombia or in the world. It is the edible olein oil, which can be mixed with soybean, with another type of oil, that is the olein and the esterin, which here is also the base for making margarine. It can be mixed with other RBD oil, which is the base for making margarine. It can be mixed with RBD, palm kernel, RBD oil, and there are other fractions of esterin that are used in cosmetics, in the manufacture of ice cream, and there are infinite uses for palm oil. It is estimated that the palm oil sector generates approximately 180,000 formal jobs in Colombia. The country is currently at the forefront in the quality of oil production, and its future looks promising due to its geographical position. So its bet is aimed at improving the quality of the transformation processes, and to venture more strongly in the field of natural fuels such as biodiesel, which allows to approach more easily to domestic and foreign markets. Our product has many outlets. Our product is a wild card. Our product is a fundamental raw material in the food line. It represents a very important advance for the farmers, because we guarantee the purchase of their product at a very competitive price, and we process it here. The market still has a lot of space to continue receiving the products we have. And we have the possibility of selling it both nationally and internationally, because crude oil is used both in the transformation processes, to convert it into final products for customers. And we also have the possibility of selling it abroad through exports. If we analyze the national context, you see that new plants are opening nationally here in the northern zone, in the central zone, if you look at the countryside, everyday cars are leaving the nursery with plants. People are convinced that we have to plant, that we have to grow the crop. So it is promising. Both the crop and the plants are growing, and as I said, the national market still fits. It still has possibilities to sell the products that we have, and we have this plan. But we also have the other plan, the export plan. We export to Europe, we export to Asia. So the crop is growing, the industrial part is growing, and the market still has a lot of space to put the products that we obtain.